In question 1, you are given a stone that is released from rest. So the words released from rest will indicate that the initial velocity is 0. So the stone is allowed to fall, and therefore this is a free falling question which involves the acceleration to be equals to g, and in this case will be 9.81 meter per second squared. Okay, this is on taking downward as positive. Because acceleration is a vector, so we need to consider the direction. Since the motion of the stone is down, it is therefore easier if we were to take downwards as positive. You can also choose upwards as positive, then the acceleration will be minus 9.81 meter per second squared. Okay, so with the sign convention chosen, downward as positive, my AT graph, the acceleration time graph, will be a constant graph where the value for A is constant at 9.81. Okay, so this is actually the answer for part B. It is easier to sketch the AT graph first because the acceleration here is constant. Okay, now we're going to do backwards. Before I do A, the distance time graph, I would like to sketch the speed time graph. Because from acceleration, we know that the acceleration is constant, the gradient of speed time graph will give you the acceleration. Since the acceleration is constant, therefore the gradient of the speed time graph will also be constant. The object is released from rest, so at time t equals 0, the speed will be 0. Next, the distance time graph. The gradient of the distance time graph will give you the speed. Therefore, we know that the gradient should be increasing. And you need to be very careful here at time t equals 0, because the speed starts from 0, so the gradient when t equals to 0 should also be 0.